Alright, hi everybody. In this lab, you're going to be testing conservation of momentum and energy for both elastic and inelastic collisions. So here's your elastic case. Alright, and if you flip your carts around so that the two Velcro sides face each other, you can force them to collide inelastically. Now with 6 lab teams of air pumps on, it's going to be kind of loud in here, so you're going to need to talk clearly and distinctly so that your team can hear you as you're communicating. In terms of the measurements that you're going to make, okay, this is the gold car, this is the red car of course, and this is what's going to pass through the photogates. We've used the concept before of using a known distance and recording time values to figure out velocity. Alright, so when you measure, go across the top of the gold cart and go across the top of the red cart. There's these bumpers here, but do not include those in your measurements because this part will not be read by the photogate. Also, when you're calculating your velocity, keep in mind that velocity is a vector quantity, so in this lab the direction of the carts will matter. Alright, now when your cart, whether it's red or gold, passes through the photogate, there's a little light on the top of this, little LED indicator that will indicate when the gate is blocked, so it'll turn on when it's blocked, and then it'll turn off when it's unblocked. Alright, because the track is so low friction, your cart's going to bounce around. Every time the cart passes through the photogate is going to record 2 times, one for when it's blocked and one for when it's unblocked. Alright, you'll need to take the difference of these 2 times to use as the time interval to which this distance passes this point in space. Work together to minimize your error, and by that I mean, once the cart passes through a photogate, stop it from bouncing back. The less data that you have on the computer screen, the less likely you are to make an error. The last tip we have for you before we start this lab is that there's a lot of data collection and there's a lot of calculations. The data tables for both the conservation of momentum and conservation of energy portions of the lab are pretty complicated. The conservation of momentum data tables, we give those to you, but the conservation of energy data tables, we ask you to create those yourself. So my last little tip is, it would be smart to walk in with your data tables laid out for your conservation of energy calculations before you start the lab. It's going to save you time and give you more time in class to do your calculations. Okay? Good luck and have a nice weekend.